Vanessa Pili, doing energy engineering, mechanical department. So here I'll be presenting to you my project titled Real-Time Solar Tracking Street Lighting System, whereby the system will have a solar tracking mechanism and also a motion sensing. So the motivation behind my project was that about 50% of road accidents happen at night due to unlit roads in Malawi, and more than 85% of roads in Malawi have unfunctional lighting systems, which lead to accidents and also bringing the safety of pedestrians and also car users at risk. So the problem statement of this project was that most roads in Malawi have unfunctional lighting system due to unreliable grid electricity of the conventional street lights that we have in Malawi. So due to this, the existing conventional street lights, they are inefficient, having poor energy storage, high cost, and also they lack smart control features. The main objective of the project was to develop an intelligent, cost-effective street lighting system that improves road safety, reduces grid electricity reliance, and supports Malawi's sustainable development. For me to achieve this objective, these are the steps that I followed. First of all was to design an energy efficient street lights with smart sensors and improved battery storage, and also to build a prototype that integrates a solar tracking mechanism and remote monitoring. Lastly was to evaluate the prototype's performance under real local environmental conditions. So for me to achieve these specific objectives, here is the methodology I used for me to achieve the specific objectives. First of all, there was conceptualization, where I came up with different concepts, and evaluated the concepts, and one concept emerged to be outstanding among the 4 concepts that I generated. And also there was system design and simulation. At system design, I had to choose components that I was going to use for my system. We have the servo motors for rotation of the solar panel, the LDR sensors for solar tracking, the Arduino, which acts as the microcontroller, and the PIR sensor for motion sensing. Thereafter, I had to simulate the system in Tinkercad, whereby I had to visually test and validate the system performance before physical implementation. So this process helped me to validate if the system is going to properly work on the ground. So thereafter, I had to develop the prototype. So I had to assemble the components. I had to integrate the hardware to implement the software in the Arduino, which acts as the microcontroller, system wiring and mounting, as well as testing and calibration. Thereafter, I had to test and evaluate the performance of the system. So the solar tracking accuracy was measured, the automatic lighting response, and also the motion detection. So this is the solution, the design solution of my project. That's the detailed, the assembly drawing, and the flow chart of how the system works. We have there atop the solar panel, which charges the battery through the charge controller, and the Arduino, which is the central processing unit, which controls and also it controls it controls the whole system. It receives signals and sends signals to the sensors and the physical components. And down here is the final prototype. This was when I just mounted this the solar tracking mechanism, and on the other end is the whole system, whereby I integrated the solar tracking mechanism, the motion sensing part. So as you can see, that's that. And from what I found from the evaluation, I integrated the solar tracker, the LED lamp, the sensors, the LDR sensor, the battery, and also I tested for solar tracking accuracy, light response, charging, communication, and fault detection. And these were the results that I found out from the evaluation. Found out that there is 92% solar tracking accuracy. The LEDs were able to switch automatically with ambient lights, and the battery was able to fully charge in 6 hours. The GSM modules was able to send status and security alerts reliably, but unfortunately I was not able to integrate the GSM module because of network issues. And also during modular prototyping, the GSM module was able to detect faults and it worked effectively. And these were some of the challenges that I encountered during my prototype development. As I already mentioned, the GSM network connectivity issues. So the GSM was not able to pick up network signals during prototyping, and also limited budgets. There were not enough finances to finance the project. And for further studies, further people should try to integrate IoT and cloud-based dashboards for advanced monitoring, machine learning-based energy management to predict lighting needs, the use of lithium iron phosphate for improved energy storage, expansion to hybrid renewable system, whereby there is an integration of solar and wind energy, and also lastly, smart city integration with traffic and security networks. And these were the references of all the information that I've got here. So the GSM module seemed to be a common problem among most of the projects that the final year students were doing. So it was a day before my project. I had to opt for other alternatives. So I wanted to use the ESP32 module, which uses softwares to communicate with the system, send signals, send alerts, and also update status of the system. So since the ESP32 module was so complex, and with the time bound that I had, I was not successful. So the challenge was not dealt with. I can say that. The plans are that if given enough finances to finance the project, because as you can see, we did this because there were not enough finances. So if given enough money for me to finance the whole project, and also if I am able to collaborate with software developers, because like I said, I am an energy engineer. I did not major in software development. So if I could have software developers in the team, technical collaboration from the city council for site deployment, I can be able to implement the project on the ground. Yes. After integrating the prototype, here is how this prototype was performing. So I'll start with this video to my left hand side. Okay, just to mention, like the title says, real-time solar tracking. So the solar tracking is on the top, whereby the LDR, the light-dependent resistors, would sense the light intensity of the sunlight and measure the difference of the light intensity and send a signal to the microcontroller, which is the Arduino. When the microcontroller receives the signal, it will send another signal to the servo motors here. There's another servo motor here, and there's another one there. It's a dual axis solar tracking, by the way. So when the servo motors have received the message, they will position the solar panel according to the position of the sun. And also during the night, the LDRs will sense that there is reduced in light intensity, and they will activate the LEDs and they will write to 30% brightness. After there is a sensor. There's a sensor there, if you can see it. There, PIR sensor, passive infrared sensor. So when the PIR sensor senses motion, it will send a signal to the microcontroller, and the microcontroller will send a signal to the LEDs to light the LEDs to full brightness. So this system optimizes energy consumption and also increases the energy capture by 25%. So here is how it works. So as you can see, this is artificial sunlight. So when you're moving the sunlight, the servo motors are positioning the solar panel according to the position of the artificial sunlight. So yeah, as you can see, still tracking. Upon removing the artificial sunlight, the LEDs lights to 30% brightness immediately. Yeah, and after sensing the motion, of course, it senses the motion when the handles just, yeah, as you can see, after sensing the motion, the LEDs lights to 100% brightness. Yeah. So this other end, I was just trying to test it if I could just turn off all the lights in this building, but it was not responding according to the way I wanted, because in the program the light intensity, the thresholds were put at very low numbers, so it was not functioning according to the way I wanted to function. Yes, that's that. Thank you.